An atom is the basic unit of matter, building block of chemistry consisting of a nucleus composed of positively charged protons and uncharged neutrons, surrounded by negatively charged electrons in orbit. The nucleus is at the center of the atom and contains most of its mass, while the electrons, much smaller in mass, move around the nucleus in orbitals. Protons. Protons are positively charged particles found in the nucleus. Each element has a unique number of protons, known as its atomic number, which determines its identity. Neutrons. Neutrons are uncharged particles found in the nucleus. Together with protons, neutrons contribute to the mass of the atom. Electrons. Electrons are negatively charged particles that orbit the nucleus in electron shells or energy levels. Electrons are involved in chemical reactions and bonding between atoms. Atomic nucleus. Nucleus is the central core of the atom, consisting of protons and neutrons. Nucleus is held together by the strong nuclear force. Electron cloud. It is the space around the nucleus where electrons are most likely to be found. Subatomic particles. Protons, neutrons, and electrons are subatomic particles that make up an atom. Protons and neutrons are much more massive than electrons. Atoms combine to form molecules, and elements are defined by the unique number of protons in their atoms. The arrangement and interaction of atoms determine the properties of substances and contribute to the complexity and diversity of matter in the universe. There are two primary models used to describe the structure of electrons within an atom, the Bohr model and the quantum mechanical model. 1. Bohr model or planetary model. Proposed by Niels Bohr in 1913. Key features. Electrons orbit the nucleus in well-defined, circular paths or energy levels. Each energy level corresponds to a specific distance from the nucleus. Electrons can absorb or emit energy as they move between energy levels. Limitations. Does not accurately represent the complex behavior of electrons. Fails to explain the fine details of atomic structure and spectral lines. 2. Quantum mechanical model or electron cloud model. Developed in the early 20th century, building on the work of scientists such as Louis de Broglie, Werner Heisenberg, and Erwin Schrödinger. Key features. Describes electrons as existing within a three-dimensional cloud or orbital rather than fixed orbits. Advantages. Successfully explains the fine details of atomic structure and behavior. Aligns with experimental observations and quantum theory. The quantum mechanical model or cloud model is the more accurate and widely accepted model of electron structure. It provides a more sophisticated and comprehensive understanding of the behavior of electrons in atoms.